Hey, it's Jim, and this is level one of the CFA program, the topic on fixed income, and the learning module on fixed income bond valuation, prices, and yields. We spent lots of good time back in our time value of money learning module computing future values, payments, and interest rates, but the most important output variable that we computed was the present value. We're going to learn today and we're going to learn tomorrow in level 2 and level 3 that the price of any financial security is simply the present value of its expected cash flows. What are the cash flows for a fixed income security? Well, whenever a government entity or a corporation issues a bond, they make an explicit promise. I promise to pay interest, which lots of times, and we'll do it here in this recording, we're going to call that a coupon payment. And then the second part is I promise to make a principal payment. A lot of times we call that a par value. So remember that price and present value mean the same thing. Have your financial calculators handy, by the way. Taking a look at just these three LOSs, skip down to the bottom. We're going to describe matrix pricing, which is an extremely fancy word for let's go ahead and take an average. We'll do that at the end, but we're going to spend most of the time, and it's a relatively short slide deck here. We're going to compute the bond's price. We're also going to compute the bond's yield to maturity. We're going to do this either on or in between coupon dates. And then we're going to look at the relationship between and among all of those variables. This should be a super fun recording. Super fun because it seems to me like these are, virtually guaranteed questions that are going to show up on the exam. But the concepts that we're going to learn here overflow into many other topics in level 1 and then on into level 2 and level 3. What do we know? That the bond's price, what did I say a minute ago? Bond's price and bond's present value. Those two concepts mean the same thing, but they depend essentially on two variables. The cash flow features, which in this case are the interest payment and the principal payment, and then what the reading calls a market discount rate. I never call it a market discount rate in my class. I ought to, but I always call it the yield to maturity on the bond. I call it the required return on the bond. I call it the current borrowing rate for that particular entity. But I think you should remember that term, market discount rate. And look at that little curved arrow point. The bond price is the present value of the interest cash flows and the principal cash flows. Now, one of the fascinating things about this reading is that at least parts of it could have been written maybe in the 13 or 1400s, way back before we had financial calculators, way back before we had time value of money tables. So I want you to look at that gray box down there. The present value of a bond is equal to the present value of the coupon payments. So that's the PMT in the numerator, and there's a subscript T. T could be in the first year, and then the second year, and the third year. Remember that bonds have maturity dates of 5 years, and 10 years, and 30 years, and 50 years, and 100 years. I mean, there's no reason why an entity couldn't issue a 1,000-year bond. And so look at that second orange point down there. What's the bond price? It's the summation. There's that sigma of the present value of all the payments, and then the present value of that future value, the FV there, that stands for maybe future value, but it's the par value of the bond. And remember this, bonds always mature for $1,000. I mean, I can say that almost without reservation. However, the convention is to price bonds based on a $100 par value. And this goes back to the old days when the Wall Street Journal had to squeeze all of this financial data into its newspaper. And so it just chopped off that last zero. So you'll probably get questions on the exam in which par value is 100. And I'm guessing the Institute will probably tell you that in the question stem. Now, one of the things that really was puzzling to me is that the Institute in this section, they give you these equations. And so you're thinking, okay, I'm going to do a bunch of time value of money stuff like I did in that very first learning module. But then the Institute says, oh, by the way, here are the functions using an Excel or some other kind of a spreadsheet function. And so we put this here down at the bottom, and you can easily get out your Excel spreadsheet and go ahead and solve for the price of a bond. It's just the PV function, and it's super easy in Excel. I have my students do this all the time. However, you're not going to have time to use the formulas. I'm pretty sure you're not going to be able to whip out your laptop and solve the problem in Excel. So I'm going to show you how to do this inside of your financial calculator. However, we're going to go ahead and show you kind of the long formulaic way to do this, so you have a picture of the timeline in your mind, and then the simplification of the financial calculator will be right at your fingertips. All right, what do we know? We know that corporations and governments, they issue bonds all the time. What they do is they promise the coupon payment and they promise the maturity payment. So I want you to think about that $1,000 par value as kind of an anchor price. I mean, bonds can sell for a little bit more than $1,000 or a little bit less than $1,000. Bonds almost never sell for $3,000 or $8,000, and they almost never sell for $100 or $200 or $50, unless that company or government body is nearing bankruptcy. So this is what we have. When the coupon rate on the bond, the coupon rate is going to give us the dollar amount of interest payment. We'll call that the coupon payment. When that is equal to the market discount rate, now that's the Institute's term here, but I'm going to go ahead and throw in the yield to maturity. So and this is what I tell my students to write in my notes, when CR equals YTM, the bond price will always be $1,000. That's always going to be the case. Now, how often is the coupon rate and the market discount rate or the yield to maturity, how often are they the same identical number? And the answer is hardly ever. And so bonds will sell either for less than 1,000, we call that a discount, or they'll sell for greater than 1,000, we call that a premium. And so that relationship in there is super fun to remember. So look at the discount bond. When the coupon rate is less than the market discount rate, now, what did I say just a moment ago? I say to my students, think of that market discount rate. Think of the yield to maturity as the current borrowing rate for that particular entity. So if the coupon rate is, let's say, 10%, and the current borrowing rate has gone up maybe 11% to 12%, that means that bondholders are willing to pay less for that bond, which is a bond that sells at a discount. On the other hand, if the coupon rate is 10% and the current borrowing rate, the market discount rate, has fallen to 9 or 8%, then that bond price will exceed $1,000, and we call that a premium bond. So this is a good relationship to memorize for the exam, because this sounds like a super highly likely question on the exam. Now, I've used this term yield to maturity before, so you shouldn't be surprised that we have a slide on it. It's the required return on the bond. It's the market discount rate. But going back to our time value of money calculations from one of those earlier learning modules, it is also the internal rate of return on those bond cash flows. So remember, when we hit the IRR button on our calculator, which you still have on your calculator, you also have an I, or maybe an I/Y button on your calculator. If you hit those two things, you'll get the same answer. Now, what is the definition of the yield to maturity? What it does, it's the interest rate, from 0, let's say, to 100%. It's the interest rate that exactly equates the present value of those future cash flows, which are interest payments and principal payment, to the bond's price. All right, so this rate of return, this concept of how much will we earn if we invest in the bond, the rate of return will equal that yield to maturity if the bond is held to maturity. I mean, most bondholders, the majority, and I'm going to say 51% or greater, most bondholders don't hold bonds until they mature, but some people do. Lots of people do. We need to make sure those coupons are paid and the principal payment is made. And here's the really really interesting assumption down at the bottom. All those coupons have to be reinvested at the yield to maturity. And that means that if the bond has a yield to maturity of, let's say, 10%, you receive all the coupon payments on time and you reinvest them at 10%. And then you receive that final principal payment at maturity date, whether it's 10 or 20 or 100 years from now, then you will have earned exactly that yield to maturity on the bond. Now look down at the bottom, that concept of reinvestment. This is going to be really important, especially when we get to level 2 and a little bit even in level 3. So for now, just remember that bondholders, they tend, how about if I say it that way, they tend to reinvest their coupon payments. Sometimes they don't, but they tend to. So we got to make some really, really great assumptions about what that reinvestment rate is. But that's a conversation for another day. Now, the learning module has a short paragraph here on the concept of what happens if the yield to maturity is negative. Well, yield to maturity is almost always positive, right? The overwhelming majority. It can be 0 or it even can be negative. But the only time yields are going to be negative is when there is some kind of a dramatic change. And the reading talks about sovereign bonds having negative yields. After the financial crisis of 2008 that led into dramatic changes in monetary policies by banks. So I'm not quite sure how super interesting that is, but don't have a heart attack on the exam if you see this concept of a negative yield to maturity. All right, how about the summary? This is all the stuff that I've been saying, right? YTM is used interchangeably with the market discount rate or the required yield or the required return on the bond. Most of the time, we don't refer to the bond price. It's mostly we refer to the yield to maturity on the bond, and we take that yield to maturity out to a bunch of decimal places. We say yields are rising. We say yields are falling. Remember, there's an inverse relationship between the yield and the present value or the price of a bond. We learned that inverse relationship back in that very first time value of money learning module. All right, so let's go ahead and get out our financial calculators here. So in this problem, we're given some dates issued by a municipality. Semi-annual coupons, 2.75%. There's face value of 100. So this bond really will have a maturity payment, a principal payment of $1,000, but to squeeze space in there, we're going to say $100. There's the market discount rate, so be ready for this to be termed yield to maturity. Be ready for it to be termed the required return on the bond. Trade settlement date, July 1st, 2035. Let's see, we're assuming a 30-day month, 360-day year. So what's going to be the price as a percentage of par value? What's the price of this bond? All right, you ready for this? So there's the green box, the formula that I showed you a few slides ago. There are the inputs on those curved arrow points going down the left-hand column. A couple of interesting things. It's semi-annually, so N has to be 10. It's a 5-year bond, but N has to be 10 semi-annual payments. So moving up, there's the yield to maturity of 3.5%. We have to cut that in half. There's the coupon rate of 2.75%. We need to cut that in half. So go ahead and look at that blue box down at the bottom, the 1.375. Those are the coupon payments. Notice that we're going to get 9 of those by themselves, but then the final payment, which comes 5 years from today, that will be the 10th payment. We're going to get our final 1.375 plus the $100 in par value. And we're going to divide by 1 plus the yield to maturity, 1 plus the market discount rate. Now we're going to raise it to the 1 and the 2 and the 3 and the 4 and all the way out to the 10th power. If you do all that math, you go ahead and you get 96,587. And that is the price based on a $100 par value or 96.587% of par value. Now, you might be thinking to yourselves, oh, wait a minute, Jim. There's no way I want to do this 10 times in the denominator. And of course, you're not going to do this 10 times. So let's get out your financial calculators. I've got my trusty 12C. Notice it's all scratched up. This thing is, I don't know, 30 some years old. All right, so what are we going to do here? We're going to make, and I need to lean over because I can't see. I can't hear and I can't see as I get old. All right, so we're going to do 1.375. We're going to hit the number first, and then we're going to hit payment. We'll do 100. That's our future value, so hit FV. And by the way, I said this to you in that time value of money learning module. It doesn't matter which order you put these in. We're going to do 1.75, that's I. And then we're going to do, what's our last one? 10 is N, and we're going to solve for present value. And I get 96,587, and that's the correct answer that we have right there. Those of you who have the Texas Instruments, remember, you're going to do this the same way. You're going to hit the number and then those 4 time value of money input buttons. And then you have to hit compute first, the CPT button up on the top left. You're going to hit compute present value and you get 96,587. So this solves for this LOS. Calculate the bond's price given a yield to maturity on those coupon dates. Now, we need to ask ourselves the question, what happens between coupon dates? I mean, remember, bonds can be traded at any given day. Coupon is here. 6 months later, the coupon's here. It doesn't mean that the bonds don't trade hands during that 6-month window. So bonds can be traded here, or here, here, here. You know, I can't do all of those slices over that 6-month time period. So what we need to do is differentiate between and among the flat price of a bond, the full price of the bond, and then the accrued interest that grows during the course between the payment today and the payment 6 months. Because if you buy that bond after 2 or 3 or 4 months, there's accrued interest in it. And you sell that bond, let's say after 4 months, you're owed that accrued interest, even though you don't receive that accrued interest coupon payment for 2 more months. So this is a super easy formula. Notice we have some circles there for you. The flat price of a bond, there's PV flat, plus the accrued interest, that's going to give us the full price of the bond. And what I want you to do is I want you to look at that light blue or how about aqua blue box down at the bottom. Notice in the parentheses, that's exactly like what we've had before. So in the parentheses, what we did before, but in order to get the full price, we need to compound it out times 1 plus some interest rate. We'll talk about that in a second. And then we need to raise it to some fraction of a power. Now, before we get to a problem, let me go ahead and just give you some details. I don't think that the Institute would test you on this, but you never know, right? This is also called the quoted price or the clean price. This flat price is probably the price quoted by the bond dealers. And what that does is it avoids misleading. So let's go ahead and take a look at how we're going to compute this accrued interest. This is super simple. We're going to take the PMT, which is the coupon payment. That's the next semi-annual coupon payment. And we're going to multiply it by a ratio of lowercase t, which is the number of days since that prior coupon payment was made, and then divide that by t, the number of total days in the coupon period. That's why we need to worry about the convention. Are we going to go with a 360-day year or a 365-day year? Now, here's a graph. This is kind of a really cool thing here. So look down at the bottom, and so you see the orange dotted line. So this, we're gaining more interest, And then when we hit the interest payment rate, we fall completely back down to 0. And then we're gaining interest and gaining interest. So the orange dotted line is the accrued interest. Now go all the way up to the top and notice that this bond sells for more than $1,000. So this is a premium bond. So notice the green, is that a green dotted line? That's the flat price. So the flat price is, well, it's flat, right? So it goes straight across. And then what happens? We just add that accrued interest. So take the orange dots at the bottom, add that to the flat price, and then you get the full price. So let me go back here just really quickly. There you go. The red plus the green equals the purple. Here we have a graphical depiction of that. So let's go ahead and work through a problem. Now, this is an interesting problem because we're given semi-annual coupon payments of 2%. So that's per year. So it's a 1% semi-annual, right? June 30th, December 31st. So that sounds fine. But then here we go to September 15th, 4 coupons remaining to maturity. The flat price using an actual day count. All right, so what are we going to do here? All right, so let's go through all this stuff. Payment is 1%, right? 1% of 100 is 1. Let's see, the market discount, there's that yield to maturity, 2.5%. We need to divide that by 2. And then skip down all the way to the bottom. There are 4 coupons remaining until maturity. So this is it's a 2-year bond. Maybe it's a 2-year note. But then I want to call your attention to the middle stuff in there. Boy, if the Institute gives you dates like this and asked you to get your fingers out and calculate, 77 days and 184 days, I mean, this would have driven me crazy. So I'm guessing what the Institute will do is they will, in the question stem, they'll say something like, you know what, that's 77 days. Or they'll have some interesting way of telling you not to get out your fingers and count all of the months, but they'll give you some really easy information so that you can come up with the 77 and the 184. I mean, clearly, on the pressure of an exam, do you remember all the days that are in every month? Do you remember any of that stuff? I have no idea how many days are in December if I'm taking this exam and I'm stressed out. Remember, even though it's been 20 years since I took those exams, I remember how stressed it was. So I don't think you'll have to calculate those 77 and 184 days. But if you do, well, then, do the best you can. All right, so what we're going to do is we're going to go ahead and compute that full price. And this was the compounding that I was telling you about. So look inside of the parentheses. What you're going to do is you're going to get out your financial calculator. And I'll do that for you here in just a second. And then we're going to compound it out to get that full price. So we're going to multiply it by 1.0125, which is 1 plus the yield to maturity on the bond. And then we're going to raise it to that 77 over 184. All right, so you ready for this? Let's go ahead and get out our calculators. Let's clear everything. So what are we going to do? Let's do 100 is future value. And let's do 1 is payment. And let's do 1.25 is I. And let's do 4 is N. And let's solve for present value. So I'm solving for what's inside of those big brackets. And I get 990305. Now, do you guys know how to use your memory buttons? This is for both the 12C and the Texas Instruments. I'm going to hit my store 1. You guys see there's a store button down here, and then hit a 1. I mean, you have 1,000 storage places. So we'll hold that back. So then what we need to do is we need to go ahead and compute that. I'm going to put my glasses so I can see this. Compute that accrued interest, because that's going to be our exponent. So even though it's given to us there, let's go ahead and do 77, what's that number? 184 divide. So there's the 418. I have 4185. And by the way, I have my calculator set to 4 decimal places. And so I'm going to put that in my store 2. So I'm going to hit store 2. So I have those. So in my memories, I've got that, what was that number? 99 something and the 0.418. So what I want to do is I want to come over and I want to compute what's going on after the multiplied sign there, right? So I'm going to say, so how do we do this in the calculator? So let's do 1.0125. I'll hit my enter button, and then I'm going to do my recall 2 and then y to the x button. And then I'm going to hit my recall 1 button and then times. And there we go, 99.5466. Well, there we go, 99.547. Now, those of you who have the 12C and I went a little bit too fast, go ahead and rewind and do that together. I got all the steps correctly. Those of you who have the Texas Instruments, you hit your buttons in a little bit of a different order, but you should be able to come up with that 99,547. So that is the full price. So we need to back out the 418. What was that? 4185 or 4186. So there's the flat price, the 99,129. So that should be okay. Let me go back and just remind you of what we're doing here. Let me go back to the circles here. So what we did is we computed the full price and then subtracted out the accrued interest to get the flat price. And that seems to be the convention of what the Institute asks you on the exam. There are 7 questions at the end of this learning module, and this is one of them. So you should do fine on this. All right, let's go to that next LOS and let's talk about some of these relationships. I said this earlier. I said it back in the time value of money learning module. When the yield to maturity goes up, bond price goes down. So there we have right at the top. Inverse relationship. So think about this. And this is why I tell my students this. Think of the yield to maturity as the current borrowing rate for the entity, whether it's the corporation or the government body, right? Think of that coupon rate as the initial borrowing rate. So when the yield to maturity goes up, when current borrowing rates goes up, well, that means present value has to go down. Remember that inverse relationship. I had a professor back in the old days who used to go like this to his students. He would say, here's the inverse relationship. Interest rates go up, price goes down. All right, how about the coupon effect? Well, this is what you have to know. A couple of things here, that bonds that have higher coupon rates, they tend to sell for higher prices. That makes perfect sense. If the future cash flows are higher, well, then the present value has to be higher. However, the coupon effect is a little bit more subtle for this. So this is what you need to know, is that when firms or governments pay a higher coupon and the yield to maturity changes, the bond price is going to change, but that bond price for a higher coupon bond is going to be less sensitive to those changes in yield. So that was the orange box down at the bottom. The maturity effect, boy, we're going to talk at length about this later on in level 1 and then extensively in level 2. We have 2 things to worry about. We have something that's known as the duration of a bond, which is totally ignored in this learning module, by the way, and the convexity of a bond, which I'll show you here in just a few moments. But this is what you need to know for this LOS. Longer-term bonds are very sensitive to changes in interest rates. In other words, if you are comparing a 5-year bond and a 50-year bond, and the yields, for some crazy reason on both of these bonds, let's say are 10%, and the yield for both of these bonds increases to, let's say, 10.5 or 11%. Well, this is bad news, right? We said this back here, the inverse relationship. This is bad news for both of those bondholders. But the bondholder who owns the 5-year bond will experience a drop in price of about this much. But the bondholder who owns the 50-year bond will experience a drop in price by about that much. So look, that's super important. Longer-term bonds are way more sensitive to changes in yields than shorter-term bonds. Now, this is called interest rate risk. So here's something great to know. Maybe not for this LOS, but for foundational material so that you're ready to dive into future level 1 stuff, is that bonds that have longer maturities, bonds that have longer durations, have greater interest rate risk. Now, suppose I give you some crazy scenario where we have a bond that has a 10% coupon rate, has 10 years to maturity, and its yield is 11%. So coupon is 10, yield goes up to 11. So that bond price is going to sell at a discount. So let's just pick a number. Suppose that it's $930. Well, what happens if over time the yield to maturity on that bond stays at 11%? Now this is totally unrealistic, but if it stays at 11% for the next, 10 years? Well, what's going to happen is that bond price is going to go slowly from 930 up to 1,000. One day it'll be 930, the next week it'll be 931, and then the next month it'll be 932, and then. So it's slowly. What do we have down at the bottom there? We have these prices are pulled to the par value, whether the bond sells at a discount or it sells at a maturity. Now, this is what I was saying about duration and convexity. Let's ignore duration, although I have a slide here in a second that I'll show you that. But what we know is that the relationship between bond prices and yields is not linear. In other words, it's not aligned. It's a curve, and that curve is called the convexity of the bond. Most bonds have positive convexity, and what that means is that there are some instances when the bond is more sensitive to a change in yield and times when it is less sensitive. All right, so two things here. Nonlinear relationship, just remember that. And most bonds have positive convexity. So let me show you a picture of this. So here's yield on the horizontal axis. Here's price on the vertical axis. So what do we know? That when yields go up, bond prices are going to go down. So look at that red line there. That red line, that would be the bond price yield relationship if prices and yields were linear. All right, so there we go. But it's not. The relationship is not linear, it's convex. So there's that green line that represents the convexity. So notice that when interest rates fall, when the yield falls, what happens? The bond price goes up. But then it has a convexity effect, a convexity adjustment. So it goes up by more than what you had thought it was going to. This is good news. If you think interest rates are going to fall, you want to buy a bond that has lots of convexity so you can capture that. You see, we have that little rectangular box up there on the top left. However, what happens when interest rates rise? This is bad news, but what happens is that if the relationship were linear, the bond price would fall by that amount. But we also have another convexity adjustment. There we go, convexity, it's positive. So you get a little bit. See the little box down there at the bottom? There's a little bit of a convexity adjustment when yields rise, and there is a lot of a convexity adjustment when yields fall. So that's probably a really, really good exam question, and why the Institute would put convexity here in this early part of level 1. Now, what did I say in the introduction? I said matrix pricing. This sounds like it's super complex. In fact, when I was in graduate school, we did matrix algebra in our econometrics class, and we had these matrices, that were huge, especially when we were trying to do a variance covariance matrix. But it's really, really not that difficult here. Let me show you what the Institute is teaching you so that you can be prepared. In fact, what did I say earlier? There are 7 questions at the end of this learning module. The 7th one asks you to do this matrix pricing, and it's exactly like the example of what I'm going to show you. Well, what do we know? When we go to the New York Stock Exchange and we want to buy shares of a company like Johnson & Johnson or Procter & Gamble, what do we know? We know that there's tons and tons of liquidity. They're actively trading. But not so for bonds. Bonds are not nearly as active as shares of stock. So what happens? What happens if we don't have market pricing? I mean, look, if I said to you, I'll give you 2 seconds to find the price of Procter & Gamble. I mean, you'd whip out your phone and you'd have it in less than 2 seconds, right? But if I said, find the price of a Procter & Gamble bond, you would say, oh, which bond? Procter & Gamble has a bunch of bonds. Oh, all right, so I pick a bond, and you go, well, wait a minute. That bond traded last week, and it hasn't traded at all this week. I don't know what the price is. All right, so what we need to do is this average or matrix pricing. So what do we do in matrix pricing? It estimates pricing using comparable frequently traded bonds. So what do? Is we try to find a bond that is, I'm just going to say the word, identical coupon rate, identical credit quality, identical maturity date, identical. We're probably not going to find that identical bond, but we'll probably find something that's, pretty similar, maybe nearly identical, maybe super similar. The learning module has an interesting graph in which it shows you, it has a graph and it has a bunch of bonds, and it tries to find the right kinds of bonds that are similar, and they turn out to be similar. So I'm guessing that the Institute is going to say, you know what, here's a bunch of bonds, you pick which ones are similar, and I'll show you that in a second. All right, so we need to identify, we need to calculate yield to maturity, and then we need to estimate the yield to maturity on the new bond or the illiquid bond. So let's work through an example here. We have an illiquid, for whatever reason, right? 6 years, 3.5% annual coupon corporate bond. 2 corporate bonds that have similar credit quality. So what does similar credit quality mean? That probably means that if our bond here is a double B rating, then these 2 bonds are probably double B rated. If they're not, then you got to go, just one on either side to find that. All right, one is a 5-year, 4%. There's the price. And the other is 7-year. All right, there's the coupon and there's the price. So notice what's happening here. Ours is a 6-year bond. We couldn't find a 6-year bond, but we found a 5-year bond. Ours is a 6-year bond, but we couldn't find a 6-year bond, so we found a 7-year bond. So we're going to take the 5-year bond, which has similar coupon, right? And the 7-year bond, which has a similar coupon, and we're just going to average those. So using matrix pricing, how are we going to do this? Well, the first thing we're going to do, we had this in the step 1 earlier, is solve for the yield to maturity on those 2 bonds. All right, so we're not given that yield to maturity. So let's go ahead and get out our financial calculator here. Now, this is important. This is a question that I didn't cover during the learning module recording here so far, but it's a question at the end of this learning module. So we're solving for the yield to maturity. Let me go ahead and say it a different way. We're solving for the internal rate of return, but we're going to use our I button on the calculator. Now, this is super important here. You ready? So let's do 4 is payment, right? Let's do 100 is future value. Let's do 5 is N. Now, we're given the present value. We're given the price, and we're asked to solve for I. So that 105.25, you have to make it negative. I tell my students this all the time. When solving for an interest rate, comma, make present value negative. So I'm going to change the sign, hit present value, and then, did I put all those in there? I think I did. Well, my calculator is running. Those of you who have the 12C, running. It takes forever. Hey, wait till you have to deal with that while you're sitting on the exam. All right, so there we go. 285.83. What do we have over there? 285, and we stopped with the 8. All right, so you can do the same thing for that 7-year bond. So this is really good stuff. What I've shown you now is how to compute the yield to maturity, or the required return on the bond, or the market discount rate, right? Remember, those terms are used interchangeably. So we get 285 and 269. All right, so that makes perfect sense. So what are we going to do? We're going to do matrix pricing. Oh my gosh, what do we do? Matrix pricing, well, we take the average, right? So take the average of those 2, and we get 2777, which we knew, right? We didn't, 85 and 69, so that's about 77. All right, so what we're going to do is that average 2.777% is going to be our estimated yield to maturity on our illiquid 6-year bond. Now, there's the equation down there at the bottom in the box. Boy, that's just time value of money stuff. Let's throw that right out the window. All right, so you ready? Let's do this. So we're going to make 3.5, make that payment. We're going to do 100, make that future value. Ours is a 6-year bond. Make that end. What did we say? 2.777. Make that I. Solve for present value. And we get 103.9457. I've got 4 decimal places. My mother used to say, and voila. I have no idea what that meant when I was little, and I don't know what it means even today as I'm in my 60s. All I know is that I loved my mother back then, and I miss her terribly. Now, the second part of this matrix pricing here is a focus on spreads. So what we're going to do here is we're going to say something like, all right, suppose, let me go back here quickly. Suppose we don't have all that stuff. Suppose all we have is spread information, the difference between the yield on our bond and the yield on a bunch of other bonds. Remember, we can have a benchmark government bond like a U.S. Treasury bond, or we can have a benchmark bond which might be one of our competitors. The benchmark might be a composite of yields of several of our competitors. And so all we're doing is we're focusing on the difference between the yield to maturity on our bond and the yield on some kind of a benchmark. And this is really super simple here. So we're going to estimate the yield on a new 8-year BBB rated bond issue. So look, we're going to pick up the phone if we're a company here issuing this bond, and we're going to ask the investment banking industry, hey, what do you think the yield on our bond? What did I call that? The yield to maturity. That's the borrowing interest rate. All right, so what are we given here? We're given a bunch of stuff. So here are the following market yields. We have a 6-year Treasury, 1.95, 6-year BBB, 3.25. All right, well, wait a minute. We have an 8-year. That's a 6-year. All right, so that doesn't quite work. So you see what we're going to do again. We're going to just kind of take an average. We're going to do some matrix pricing. Well, there we have a 10-year Treasury 2.7 and a 10-year BBB at 4.3. So we're in the middle. So we find the 6 and we find the 8. What did we do in the previous example? We had the 6, so we found the 5 and the 7. So now we're going 2 on either side. So the 6-year and the 10-year. But then look, down at the bottom block point, there's the 8-year Treasury yield to maturity, 2.3%. All right, so estimate the required yield. What is the yield to maturity on this new bond? And all we're going to do in our matrix pricing, I'll go ahead and give it that fancy name, is we're going to take an average like we did before, but this is going to be way easier. All right, so what are we going to do? The spread on the 6-year and the spread on the 10-year. So the 3.25 minus the 1.95. The 4.3 minus the 2.7, so that's just back here, right in the first 2 bullet points and the second 2 bullet points, and then take an average. So 1.3 and 1.6. There's the 1.45, and then that's the average spread. But then we need to drop to the bottom block point there. There's the 8-year U.S. Treasury bond. There's the yield of 2.3. So we're going to add our average matrix pricing spread of 1.45. So 3.75. So there's our estimate. Let me go back here. There's our estimate of the yield to maturity on our 8-year BBB rated bond. Shouldn't be surprising, right? The 10-year BBB was 4.3. The 6-year BBB was 3.25. And so we shouldn't be surprised well, there you go, 3.75. All right, this was really super fun, and it was super important because we're going to do this stuff forever and ever, or at least through level 1, level 2, and level 3. So what I want you to do now is I want you to keep your calculator out. You'll have to use it for a handful of problems. There's 7 problems there. Give yourself 15 minutes or so. Work through those problems, and I think you'll be able to handle these LOSs on the exam. So, hey, have a great day. Thanks for watching, and good luck studying.